Hi everyone, my name is Anu, and as you're introduced, our team worked on problem statements regarding land degradation, drought, and peoples, and we are the Policy Agent project, which seeks to empower you, the policy analysts, through AI and geo-based insights. Yeah, this is our team of 6, and we come from a variety of different backgrounds of technical and subject matter expertise, from satellite data, environmental policy, data science, AI app development, product, and more. So the issue of land degradation isn't just an indicator of the damage that our environment is going through, but it also is an issue that exacerbates and intensifies socioeconomic crises. So in sub-Saharan Africa alone, land degradation leads to the threatening of livelihoods, triggers conflicts, and it exacerbates inequality. And for example, in Somalia, traditionally clan leaders are the ones that manage resources and make sure that land access is available. And because of these issues, there is an increase in land conflict, which leads to more prolonged violence. And unfortunately, it's not a unique case. So currently, the UN uses manual aggregation of vast, complex, and disparate data sets. And that's very time-intensive, energy-intensive, and requires a lot of technical expertise to manipulate. So our new solution seeks to really speed up that process and make sure that our policy analysts are able to effectively empower the work that they do to shape and monitor policy through AI. And to share that our work over this past weekend, we're going to show a demo from one of our engineers, Clovis.
I get a print play.
There's a cat play.
I did with it, which the last L1 China. It was isolated looking at giving mid-sized small to gaps in their data, helps to compare data locally available to data that we just about, or just in the world, but not integrated with your product. And then the analyst, which when you're actually looking at regional, looking at something, can give you more insights into the problem you're dealing with. And so let's get into an example of that. And so let's say you're looking at and you say one of the problems you're looking at, and that you're pointed at by some of the folks who were at the event, were data fluoridation, or the relative at extreme violence and desertification. So you can ask that, and the outline will show you some data sets that's available. Right now it's showing mostly the local ones that we just doing the machine. Of course, there's heavy like internet and give access to possible range data sets. Here it's pulling up one data set, which is a violence data set worldwide from the satellite, and another one, which is multiple land degradation data set, giving you some information about the data set, time ranges, and sort of the pros and cons of the data and the hypothesis. And then it wants to another one, case study, in small case. So we say, oh, it's interesting, tell me more. Small. And so as it runs and it gives the data set develops, give you more information about it, give you more context, things like that. And you say, great, now that you've decided this data set you want, you would, let's say, have a button to add as a map. So in this case, pop the screen over here, that is also send a map. So great, notice on the map, click on the region we're looking at, and then opens the analyst tab. And now the analyst tab is a model that actually has context of what we're looking at. So here we have a couple of different map views. This one's overlaying right now as each grid cells the violence data set over the underlying desertification data set, showing that physical protect land use in the region was the data set associated by deaths, military pollution. And so because the L1 has access to the legend, it has access to basically the like data you're looking at, it actually understands what you're talking about. So what do I mean with that? Well, let's say I'm approaching this particular violence stakeholder, I could say, clockwise is the south sunlit. And the model, which actually understands what the color is, the red veins, it states the violence experience, it explains that the specific regions where violence occur, and to give you more information about intensity, conflict, historical, or geographical reasons, and just give you that expertise that an L1 can bring directly to someone who is supported in nutrition. And so is a problem that altogether you're able to then, let's say you ask about is the problem, is that bad thing? How can we make that seeds come? And so And so the model then gives you recommendations of policies, gives you recommendations including to mediate those areas. Right now, this is of course just formed through LLM context, and it's called AI. But in general, if you actually follow this, get UN documents, look what that was, you can start to have a better idea of what options are available given the situation we're looking at. And so we're hoping that this whole thing together will help policymakers make more effective decisions more quickly, more easily, and basically be able to make our world a better place. And so one last interesting thing is, if you decide to review that you enjoy and you like what you're looking at, you simply click export CSV, and then boom, you'll get actual full CSV, all the information, HTML grid cells that you're looking at, timestamps, et cetera, of the data set you're interested in. And so this is to allow rapid sharing, more quick sharing of data sets between folks. And so this is a complete picture of the project we have one, and we're really hoping that this can help to, in the ever-changing world we have now, ever-growing conflicts and problems that we're facing, we can bring a little bit of this AI tools, this AI expertise to the front and help people to improve the lives worldwide. Thank you very much. We essentially have a twofold approach where on one hand,
sorry, yes. So we need to cut it down at this moment, so just wrap it up, please.
Yes, I can do that. So this is our data flow diagram. Just real quick, all of our backend is actually just Python and Quad 5 through Quad 5. Our front end is reliant on DevGL and H3, which are tools built by the Uberviz team. So this is all really, really cool. Like our data assistant tab and analysis assistant tab is also Claude. And our impact potential is immense. We're directly targeting SDG, which is Sustainable Development Goals developed by the UN, regarding land degradation and conflict-related deaths. But of course, the environment is interconnected, and there's a lot of goals surrounding biodiversity, water access, and poverty, and water ecosystem protection that this can encash. So these are our next steps. We're really focusing on making our visualizations more impact-driven, expanding our data sets, and adding more powerful agents to make sure that we can collect as much data as possible and provide insights that are most relevant to our young policy analysts. So thank you. And this is our contact info if you want to learn more about the project and work with us moving forward. Thank you again.
Thank you all. So I guess we all learned one lesson. So you cannot win a hackathon without showing up. And as I can see, all the people right now in this room on Monday, on a holiday, discussing AI for good, you qualified to win a hackathon. So show up, go get them, and let's make the future brighter with AI. Thank you all.